Good morning, everyone. Welcome again to second day InformEx. I wanted to kick off this event with a few thoughts for you. Lots of things have changed. We were here this time last year, almost 1 year ago to the day, and lots of things have changed in this world. You think about it. Oil is at $30 a barrel. It wasn't supposed to be. The dollar is almost on parity with the euro, and I don't think anybody thought that that was going to happen. It's affecting us profoundly. Donald Trump is running for president. Who thought that was going to happen? Oh, and here's a good one. Hillary is not the presumptive nominee for president for the Democrats. Who thought that was going to happen? DuPont, Dow, going to be the same company soon. And this morning I read that our friends at Syngenta and China Chem, who thought that was going to happen? But I can give you one sure bet for InformEx in Philadelphia next year. No one will know any better then than they know now what's going to happen. That's a sure bet. Which brings us to what these guys are about to talk about. Let me introduce them. Gary Johansson, DuPont. Bob Bryant, Valeant. John Anderson, Dow Chemical. Who knows?
Or
whatever. And Scott Harding with Syngenta today. They've agreed to come and talk to us about the research in the crop protection chemicals business, which is important to a lot of us because it includes us in our supply chains, all the contract manufacturers. So what I'm going to do is turn it over to them and let them give you a feel for what's going on in each of their businesses. And then at that point in time, we'll take some questions and answers. And they are betting the farm on what they're getting ready to tell you, not $30 barrel of oil, okay? Take over, Gary.
All right, good morning, everybody, and welcome. My name is Gary Johansson. I work for DuPont Crop Protection. Will at some point be DuPont Agrosciences when we merge with Dow. My role is as a manufacturing technology manager. I formerly held a role in R&D. Last time I was at InformEx, I was in an R&D capacity. But as manufacturing technology manager, I have responsibility for formulations and packaging sites in North America. I also have responsibility for some contract manufacturing and for quality. So as this merger happens, they tend to put more and more on us. So I've got quite a few roles. I just want to talk a little bit about DuPont and how we realize innovation, and that's the topic of this panel. So I'll just go right to the charts. Okay, so it's been a tough year in the agrochemicals business. I think everyone's feeling the pain. Lots of currency headwinds for sure. Collapse of the Brazilian real. So a lot of headwinds, but the realities really haven't changed. We have a population of 7 billion that'll grow to 9 billion by 2050. We still don't produce as much as we consume or need to consume. That's not going to change. And we see a robust growth long term, even though we tend to be in a down cycle right now. And on top of that, pest pressure never stops. Okay, might stop 1 year, but it'll come back another year.
Sorry.
So basically, DuPont Crop Protection really is about a robust pipeline and realizing our potential. Our mission is to increase yields across specialty crops, row crops, increase the quality of crops. We also work very hard to raise production levels for our growers and increase their profit potential. That's part of our mission. And at the bottom line, we want to improve the quality and quantity of food. We want to make sure that there's a plentiful, nutritious supply of food for a growing world population. So where are we located? DuPont Crop Protection right now is a global company. We have 20 R&D sites across the globe, 26 manufacturing sites in 10 countries. And I should highlight on the bottom here 4 of our research centers. We have one in the United States, about 350 people at our Stein-Haskell Research Center, Paulínia Station in Brazil, and we have an R&D center in Namsha in France, and a knowledge center in Hyderabad, India. So what do we look at as sort of our advantage, or we feel that we're advantaged? Now, first of all, our goal is to commercialize one new molecule every year. We've been pretty good at that. You'll see our pipeline. We've launched a new molecule every year since 2009. We look at safety first, crop safety, human safety. We try to fail early in our development process. Okay, it's very important to us. We don't want to invest $250 million, in something that's going to fail, halfway through our pipeline. I want to see the big picture. Consider everything. Consider the grower. Consider the markets. Consider the country. Consider the crop. All of the big picture, and also identify potential issues. A big part of what we do also is we try to maintain very strong relationships with regulators around the globe. So we do have a very good track record of bringing things to market with relatively fast regulatory approvals. So again, we consider that an advantage. So let's talk about a little bit about how we discover molecules. And for many people here, this is one of the, I think, things that you're all interested in. You've seen our chemistry before. So DuPont Rynaxypyr is chlorantraniliprole. This is really the biggest blockbuster insecticide in the world. It's the largest selling insecticide in the world. It was launched in 2009. You can see the testimonials on the left. And what we typically do in terms of our discovery process, we have a discovery group, discovery chemistry, discovery biology, try to understand mode of action, site of action, try to look for early hits and leads, and then once we identify these, we try to bring them through, fail as many compounds as we can, and then to bring the blockbusters through into our development pipeline. So in the case of Rynaxypyr, this is a chem-based design discovery. So basically we look through the patents, we look through the literature, shuffle things around a little bit. And once you shuffle it around on the right, you see a hit. And then we go, and after about, 2,500 analogs or so, we get to the active compound, which is a novel mode of action insecticide that's used on specialty crops throughout the world. Okay, another thing that we'll often do is a big important part of our strategy is property modification. So if you look at this molecule, this is Cyazypyr. This launched in 2012. Again, it's an insecticide for specialty crops. And here it's a matter of property modification, try to increase the uptake in the soil and make this compound, this great insecticide, a little bit more systemic. So again, a lot of analogging around our Rynaxypyr molecule. And if you look at it, you'll see 1,500 analogs just to make one little tiny change. We changed the chlorine on the left to a cyano group, but it has profound impact on the activity of this molecule. This is one of our newest molecules that we just launched in 2015, Zorvac, or oxythiopyperlin. This is a fungicide, and what we did here is we have access to large volumes, libraries, chemical libraries. If you go in DuPont, we actually put compounds into the library from other businesses in DuPont. We take libraries from wherever we can find them. In this case, this HZQ10 hit came from one of these libraries, and then after about 300 analogs, about 1,800 analogs, we eventually settled on oxythiopyperlin. This is a fungicide that we're launching now. So this is just an outlook of our pipeline from 2008 through 2020. This does not include a lot of our, specialty blends and growth and renewal kind of activities. There's a lot of other activities out there, new registrations, new crops, but this really is looking at new molecules in the pipeline. And as you can see, starting back from a Canto approach, that's a picoxystrobin, which we acquired from Syngenta, through to Rynaxypyr, our own insecticide. Vertisan is a fungicide that we commercialized in 2011. Cyazypyr, and you can see we still have a robust pipeline. Again, our goal is to launch one new molecule per year, depending on business support. Okay? And last, I'd just like to point out that, we want to recognize the efforts of our people. We have a very strong R&D group. It's a very small R&D group, relatively productive, very, very productive team. About 350 researchers in the Wilmington area that have generated most of this pipeline. So some of our awards are shown here. I won't go through them all, but you can take a look at them. But I think these are all very, very prestigious recognitions, and we look forward to continuing to develop this pipeline. Thank you.
Well, good morning. I'm Johnny Anderson. I work for Dow Chemical. Much of the work that I do for Dow Chemical is in partnership with Dow's Ag Chemicals business known as Dow AgroSciences, headquartered in Indianapolis. I happen to be located in Midland, Michigan, been there for my entire career. But we do support of the Dow AgroSciences business in the form of process and product development in partnership with some of the folks that supplied the slides that I'll share with you this morning. In fact, I would characterize myself as a guy who basically raided our Discovery folks' homework bin, stole it from them, and now we'll proceed to pass it off as my own. But
yeah, launch is not on the screen.
oh,
So there's a mouse on it.
this is the mouse here.
Just have to click on that.
All right. Can't find the mouse.
There it is.
Got it. Well, now you can see the slides along with me. Just apologize for that, and on the chance that you didn't know you were at the InformEx show, here's some reassurance for you. But thanks for joining us today. What I did with the homework that I pilfered from our Discovery folks is I just kind of reviewed it to make sure that I felt good about turning it in, and then summarized it in this particular slide here. Tried to identify it in the top box. What did I see as sort of overarching trends when I read the data that you're about to see that supports some of these conclusions? One was increased cost of development, and I've got, like a data person or a research person, I'm a data monger, and I've got some papers with me that I could share with you if you have interest in where these numbers came from. But the cost of development has gone up for a variety of reasons that we'll talk about: regulatory pressure, loss of efficacy as insects and weeds develop resistance, all the things that you probably are aware of. But cost is a bottom line driver. Along with that, speed to market. That's becoming a bigger issue because it takes longer for us to develop more difficult products. They're harder to make. It's harder to find homes for them as far as manufacturing locations, this sort of thing. So that timeline's dragged out, and doing everything we can to trim time out of that enables us to, market and sell the product, without significant competition. So that's a driver. New modes of action. That's a big buzzword for our Discovery folks in Indianapolis, and this has obviously to do with insect and weed resistance that develop, after they've been pressured by a particular pesticide for a little while. They get smarter, and so new modes of action are our way to try and stay ahead of those kinds of things. And then finally, I quoted greater pressure for green chemistry from somebody else. And if what you mean by green is sort of the ecological things that we're all trying to respond to in our jobs, that's one thing. But I think also in some of the data you'll see there's pressure to try and insult only the insect or the pest and try and protect other beings like mammals and birds and bees and this sort of thing. So you'll see some data in just a second that shows that we've done a remarkable job making those kinds of strides in the marketplace. So basically, more selective process for identifying materials because it costs more to bring them to the market. Acceptance of molecular modeling is a comment that was made to me by my colleagues, and this basically enables us to use computers to do what we might have used to done with a shotgun in some kind of a greenhouse experiment. So we're doing a little bit more of a smart approach to trying to defeat the pest. The quality of the assays and the tools have improved necessarily because of regulatory pressures. And basically you'll see in a couple of slides that the molecules indeed are getting more complex, and I think this overlaps, of course, with what Gary shared with you already. At this point, I would characterize most of the chemists that I work with in the discovery phase as folks that easily could transfer their skills into a pharma or a medical field as a chemist. So there's a little bit more of an overlap in the kinds of work that they do, and that's increasing all the time. You can almost observe that in the places that we recruit and the kinds of folks we recruit to do the work as well. a big driver for us in both R&D and, for that matter, in manufacturing, which you'll hear more about from some of the other panelists, is a drive toward getting third-party assistance as far as doing research with us and doing manufacturing for us after the molecule is commercialized. We'll move on. Now we'll talk about the data that I promised you. Hopefully you can read this slide, but on the y-axis you basically say how many active ingredients have been launched over 5-year periods, and you sort of see a crest in the middle of the graph, and in the last 10 or 15 years this has dropped off. I don't think this is inconsistent with Gary's experience at DuPont, where they're launching one new molecule a year. I think the phenomena that we're really observing here is there's fewer companies in the business because the cost of developing these molecules has become high. So while companies that have the horsepower that DuPont has can launch one new molecule a year, there's just been an atrophy of other competitors, and so you're seeing, as a consequence of high cost, you're seeing a more selective process when it comes to launching products. These two graphs here I hope you can read. The first one has to do with vertebrate or selectivity of the product. On the x-axis you've got time, and the y-axis basically is a number that I couldn't recalculate for you, and I don't know what the basis is. So again, I did steal someone's homework, but I think if we accept the fact that these are in relative terms the same number from left to right, what it says is that over the course of time the selectivity to the target pests has grown by orders of magnitude. And that's sort of typical, and the little arrows with the boxes refer to specific product compounds that are in the marketplace, not just Dow AgroSciences compounds, but how would you characterize each of these launches over the course of time in terms of their efficacy to the target pest relative to their toxicity to other organisms. And obviously that's a real attribute and I think a real trophy for the industry and the folks that are developing products. On the right-hand side, it's sort of the inverse of the left-hand graph, and in essence it says that application rates have been tumbling down, and again there's a whole series of compounds that are listed there that you may not be able to read from your chair, but this is data that I've got from a paper, and I could share that with you if you just have casual interest in that kind of thing. But those are trends that I think we're going to see continuing. And so I'll just close with, in deference to the folks in the group who are chemists who can actually read these kinds of things. I'm a chemical engineer by training. You can see that the complexity of the molecules as measured by molecular weights, as measured by number of functional groups, as measured by chiral centers, these sorts of measurements has grown over the years, and we continue to see that. The processes and the molecules continue to get more difficult to make. The role that I play at Dow AgroSciences is to, at an early stage in the product's lifetime, determine what we think it might cost to make with some models that we have and with interactions with folks like yourselves, where you share with me pricing information, whether you be a third-party contractor or a raw material supplier, and I bundle all that together. And I really like the phrase that Gary used, and I'll just close with that comment, is one of the objectives and one of the things that we can do in our development organization is fail early. And so when somebody presents us with a baby and we have to determine whether or not it's beautiful, we try to do that rather quickly so that we're investing the resources in the right places. So that's all I had for you this morning. I'll welcome some questions after we're done. Thanks.
Good morning. I look around here and I see some familiar faces, and I see some people that are probably wondering the same thing that I wondered when I was asked to do this presentation, and what the hell is he going to talk about? And as of last night, I still didn't know. I ran into a few people that have had projects with over the last few decades at InformEx, and I got no shortage of suggestions yesterday of, well, this was innovative and this was innovative, and I got to thinking about that, and I thought, well, what is innovation? When I was asked to do it, I went to Webster's and I looked it up because I had an idea what innovative meant, but we have a product called Innovate. It is innovative, but innovate is a novel solution to a problem or a novel understanding of a problem, and over the course of the last, say, 30 years, feeding the world has been an issue and a problem. How we've done it the past 20 years or so is by exploiting more arable land. We're tapped there. Does anybody remember the 80s? The world events in the 80s? Okay. So, to me, I look back at the 80s and I remember Chernobyl. I remember the Challenger blowing up. I remember Michael Jackson's We Are the World. And I remember some of the quotes there. And David Bowie was on the recording, and he said, "It's Christmas of 1984. And there are more starving people on our planet than ever before." I haven't seen a recent statistic on that, but I believe that statement is still true, if he were alive today. So innovate is usually a solution to a problem. And since 1984, we've innovated by exploitation of more and more arable land, but we come no closer to feeding the population of the world. So there's a challenge for you younger people here. How will we feed the world's population in the next 10 years? Going to Chernobyl, I read a statistic recently that just alarmed me. Did you know there's a commuter train from Paris to Chernobyl? That 3 times a day, you can take a train from Paris to Chernobyl. Why the hell would anybody want to go there? There are more people employed at Chernobyl today than there were when that plant was operating. The technologies that are going to be required to clean that mess up are still being invented. And that's 30 plus years ago. So this is where innovation is needed. This is where, when you're challenged with a problem, you come up with a solution to it. Just a few short years ago, there was a nuclear incident in Japan from a tsunami wave. The technology cleaning that up is still being invented. It still needs to be invented. So I wish there were more younger people here. Over the last 2 decades, I've seen the InformEx expand and contract. And a lot of people are suggesting that this is a trade show that might not survive. I think that would be a tragedy, because this is my this is where ideas are born. I came here, yesterday to figure out the speech and understand the logistics in here, and in meeting with 2 vendors, I paid for my trip, and so the cross-pollination discussions that you guys have here today, you don't mean to realize what that does to your viability, your tomorrow. So I would urge you to think about where you learn, where your resources are, and innovate as needs arise. I'm an engineer. I'm not used to really talking in front of people here. Like I said, I didn't know what I said, and I don't know if I've said anything. But we tend to introvert a little bit, and I just kind of end with, if I can, a quote. Let's see it too.
I want to see it too. Sorry, Scott, I didn't toggle your slides up. So.
Oh, that's fine. Oh, now it's not going to do second screen.
Well, they're working on getting my slides up there. I'm Scott Harding. I'm a formulation and tolling team manager. Formulation, can you hear me now? No, not me.
Is that you?
Nope. So while he's doing that, you want to set this one? Can you hear me? Okay. I'm Scott Harding. I'm formulation and tolling team manager with Syngenta, based out of Greensboro, North Carolina. My presentation, I'm going to go through, you might see it, you might not see it, will be more from a customer focus, customer feedback. How do we take information in that helps really drive our innovation, and then how do we leverage that within the strength to provide solutions to the marketplace?
Can't get to it.
So if you can do view, you might be able to do the second screen setup and actually show it on both. You might have to go to properties on the desktop. Okay. Well, one of the things that affects the ag business, and one of the prompts for this, is really understanding resistance. And so weed resistance is a big challenge, but it also is a good opportunity for the ag business. So as you're looking at stacked resistance, multiple species of resistant weeds, pests, you know, those challenges that affect the grower, that affect the yield of crops, also present a great opportunity in order to, all right, now we're cooking.
Okay, so it's not going to show just the slide, it's going to show the tab, just duplicate.
That's fine. Yep, okay. So again, resistance is spreading. We've seen major increase over the last 4 years. Can you hear me now on this one? I'll keep with the hand mic. So what's that resistance doing? It's causing increased sprays, increased residual herbicide use, which basically makes the problem worse. If you're overspraying everything with glyphosate, you randomly get a glyphosate resistance thing. It just kind of happens. So as you're looking at that, how does innovation, how are we bringing forward new molecules, new technologies in order to address that in a proactive, kind of sustainable way? So you look kind of like an innovation wheel here. So how do we take this information? How do we take the yield? How do we take the performance, the pest pressure? How does that drive and shape where we focus our research? The fail early, fail often. Where are those challenges? Where are the opportunities where new products can be a blockbuster, can be a hero brand that comes through? So understanding resistance mechanisms to active ingredients, pest pressures, understanding where the grower's needs are. How does that then turn into innovative products, new solutions, multiple AI formulations, new AIs to attack specific resistance problems, issues. And beyond that, one of the things with Syngenta that we provide is not only just product innovation, it's actually using data and providing systems and tools and proactive management to our growers. So not only is it application of new molecules, it's how you apply it, where you apply it, when you apply it, that allows that specificity, so you reduce the amount of spray, you get more effect for what you're trying to apply. So that also kind of continues the loop. So as you keep going through that, it continually shapes, refines, focus where you want to approach, where you want to apply new technology, or where you have new opportunities. Another thing that really kind of helps is how do you segment your customer base? Where do you see the benefit? Where do you think new opportunities, new adoption of technology, where that new molecule will be able to be sold, and a lot. So this graph here shows segmentation of weed control strategy based on grower, location, application size, and then price versus performance focus. And so really, if you look at the red circled area, highlights where opportunities that the higher end, higher price, more technology driven growers are really going to be looking at new technology to improve yield, to improve performance. So as you're improving yield, you only have a set finite amount of land that you can grow on, so how can you get more per acre? And so that's kind of where a lot of opportunity to then go address that market. So similar from a case study standpoint, this year we launched a new a new formulation, Acuron. It's a corn herbicide with a new active ingredient, bicyclopyron. Key innovation here is taking the feedback from customers. So it's a stacked 4 active ingredient formulation, multiple modes of action to go after different tough weeds. Overlapping allows kind of, based on that, built-in weed resistance management, broad spectrum control, season-long control of weeds. But the nice thing is it allows one-pass treatment. So in areas where it's too expensive, too complex to do multiple sprays, it allows that control. The other aspect is it gives you a wide window of application. So you have the ability to burn down before planting up to 28 days before planting, all the way through post-emergence up to about a foot tall corn. So you give a real broad window and be able to apply. And so that's one of the things where you listen to the feedback and you see opportunities and come up with a product that was launched this year. So when you look at product development within Syngenta, foundationally we have active ingredient synthesis as a core. Internal, external manufacturing, leverage key supply relationships that help with ongoing production, as well as development of new molecules, so intermediates, advanced intermediates, so even full production at the end. Really, market data helps focus where we have those opportunities. The quick screening is a little bit further, upstream of this, and then really feeds into the extensive innovation pipeline that feeds into that. In addition, formulation is a key strength. And so it's really taking that stable of all your active ingredients and how are you able to then customize, rapidly deliver a tailored product by crop, by region, by pest pressure to hit exactly what the grower is having an issue with. How do you provide that so you're reducing your application rates and really niche on what that one specific grower needs. So it's a real hand-holding with the customer, and then supply chain to be able to deliver that. So internal, external manufacturing, distribution channel to be able to get the product when it's needed, where it's needed. So in summary, how do you look at grower input as the definition of opportunities? Weed resistance increasing, desire for one-pass application, wider window of application timeline. So how do you then use that as the key challenges to define what your product development is? So with Syngenta, robust AI development, formulation development expertise, 4 AIs, stable in customer systems, and then really how all that is leveraged from the sales and R&D, and then from a production standpoint, really leveraging the full breadth of the organization in order to deliver that and provide innovation to the marketplace.
Thank you, Scott. Thank each of you for coming today and sharing what you do. We've got some time for some questions and answers. And I've got a mic here. Number 3. Anyone with a question?
Will Ziegler with Monsanto.
It's your fault.
So, am I on? No. So I'll just ask the question loudly then. So I heard a lot of discussions around the growing complexities with molecules and how we look back in the history and we see a very unique, you see a very simple carbon chain, and now all the way today we've got these molecules that have all these different configurations. My concern is that at some point the cost of innovation is going to exceed the value of the innovation. Could you please speak to what we're doing in our R&D processes to try to reduce the cost? Thank you.
So for us, as I was in R&D and it's integral to this process, what we do is, as I said, we try to fail fast. We do put a lot of molecules in. We look for hits very early, but we try to eliminate them as quickly as possible. How do we manage cost? What we try to do is we have a variable model, which means we try not to staff up really big in our R&D departments. It costs about $250 million to develop a new AI. all the way to formulated products and registration. So what we do is we rely on contract research organizations. We rely on supply chains spread across the globe. Cost is absolutely critical, so we have to maintain that. We use economic evaluators very early in the process to understand what's the impact of our routes on our NPV. So we really have to understand that early on. Often I see suppliers will come and say, hey, I have an idea how to make that molecule. By the time you see our molecules, we've already gone through the regulatory process. So, I mean, really it's all about understanding very early on, managing those costs and leveraging the, third-party partners as well.
Okay, anyone else? Another question. That was a good question, by the way. Well, we certainly agree that they all have challenging opportunities ahead of them. You've got to feed the world, is that right? That's the part of it. 9 billion people before long. But we appreciate each of you coming today, and we'll see you next year probably.